Sir, shall we start?
Yes, sir,
Okay.
please.
Yeah. Good morning, friends. It is an honor and a great pleasure to welcome you all to this Foreign Browser lecture series. Now I would like to welcome Dr. Asadi Srinivas, who has accepted our invitation to give a talk on data science applications using ML and DL techniques. Dr. Asadi received BTech Computer Science and Engineering from Sri Venkateswara University in the year 2000 and completed his MTech in Intelligent Systems from the Indian Institute of Information Technology, Allahabad, in the year 2004. Also, he received his PhD from Jawaharlal Nehru Technological University, Anandapur. Currently, he is working as head research and professor of information technology at Blue Crest University, Monrovia, Liberia. He has 19 years of teaching and industry experience. He has published more than 195 papers in reputed international journals and conferences and attended 200 plus workshops, symposiums, and seminars. He has acted as a resource person for more than 115 international and national conferences, workshops, symposiums, and seminars. Let us invite Dr. Asadi to give his talk. I hope you all will enjoy the session. Thank you. Over to Dr. Asadi.
Yeah, thank you, sir, Jan Singh, sir, for giving me this wonderful opportunity to interact with uh, VIT students and faculty members. Sir, my voice is audible?
Yes, sir. You are audible. Please proceed.
Yeah, please record this
Yeah,
video, sir.
yeah. Recording is going on, sir. Yes,
Yeah.
thank you.
Yeah. Very good morning, one and all, my dear students. Today, I would like to discuss about data science applications using machine learning and deep learning techniques. Today, I am going to demonstrate various health database applications such as COVID-19 virus prediction and detection and Omicron virus prediction and detection, monkeypox prediction and detection, like breast cancer, lung cancer, prostate cancer prediction and detection by using machine learning and deep learning techniques. Before going to my topic, within 60 seconds, what is happening in this world? How many users are connected to this internet world? Can you imagine how many number of users are connected to this internet world? See, approximately 3.8 million search queries are searching within 60 seconds. 1 million logging in Facebook, 18.1 million text sent, 4.5 million videos viewed, and 6,94,444 hours watched in Netflix, 1.8 million emails sent. That means how many users are connected to this internet world? I I want to demonstrate with practical. If you see this URL www.internetlivestats.com, if you click this URL, you are redirected to see now my screen is visible.
Yes, sir. It is visible.
Yeah, now see internet users in the world connected right now. Can you read this number? Very tough. 5,498,292,900 users today.
Sir, your voice is breaking.
tweet sent connect network of
Sir, your voice is breaking. Asadi, sir, you're not audible.
This internet. Hello,
Hello.
sir. My is visible, sir.
No, sir, it is not visible. And moreover, your voice is also breaking.
One second, sir.
Yeah, now it is visible, sir. Yeah, please proceed.
So that means how many users are connected to this internet world? So that's why we are going to see the backbone of cloud computing is virtualization and a data center. Data center is nothing but high integration computing servers at one place is called data center. Virtualization means the ability to perform multiple tasks in a single system is called virtualization. And Gmail is the best consumer of cloud computing. And that is the reason I'm explaining where the data is coming from, how the data is storing in a data center, how many servers are required. So those things I have incorporated in this image. How many Facebook users are connected? How many users are viewing videos in the YouTube, etc. So data today, I'm going to explain and demonstrate various concepts, introduction to data science, statistics, and by using Python programming, I'm going to demonstrate various applications, then followed by the artificial intelligence concepts and tools and techniques, data mining tools and techniques, artificial neural networks, machine learning, and deep learning, and followed by the various applications I'm going to demonstrate. COVID-19 virus prediction and detection, Omicron virus prediction and detection, Ebola virus prediction and detection, prostate, breast and lung cancer prediction, monkeypox prediction and detection. So, computers understands only ones and zeros. If you press information interchange, capitals, you will get number is 1. That's why 1 bit is equal to 0 or 1. 4 bits, 4 bytes is equal to 1 word. 1024 bytes is equal to 1 bytes, hexabytes, octabytes, zettabytes, yottabytes. Yesterday I have checked two more terminologies presented. 1024 yottabytes is equal to 1 brontobyte. 1024 brontobyte is equal to 1 geobyte. 1024 geobytes is equal to infinity. If you see same terminology in mathematical range, kilobyte is 10 power 3, megabyte is 10 power 6, gigabyte is 10 power 9, terabyte is 10 power 12, petabyte is 10 power 15, hexabyte is 10 power 18, zettabyte is 10 power 21, yottabyte is 10 power 24, brontobyte is 10 power 27, geobyte is 10 power 30. So, in introduction to data science, I am going to explain what are the fundamentals of data science, components of data science, workflow of data science, explain. So data analytics using statistical methods, data analytics using AI techniques, data analytics using data mining techniques, data analytics using artificial neural networks techniques, data analytics using machine learning techniques, data analytics using deep learning techniques. So then Python programming, then advanced Python programming concepts, then Go programming. Recently, I'm using Go programming in order to develop data science applications. Then statistics, what are the techniques I'm using? Then artificial intelligence tools and techniques. Then data mining approaches like classification, clustering, association, rule mining, artificial neural networks, what are the single layer perceptron, multi-layer perceptron, self-organizing maps, etc. Then machine learning frameworks like supervised learning, unsupervised learning, reinforcement learning, then followed by the deep learning techniques by using augmented applications. These are the projects I have developed in my data science research laboratory. So nearly 100 projects I have developed in my research laboratory. So last application is Twitter dataset classification using deep learning techniques. So before going to data science concept, what is the prerequisition of data science? You must have knowledge on statistics like inferential statistics and descriptive statistics. We must have knowledge on mathematics, linear algebra, calculus, any one programming language like Excel, Python, or SQL. And this chart is prepared by me. Experience, I have prerequisition of data science. Raw material facts are information is nothing but process. Data is called database. To manage the database, we are using this relational databases and non-relational system, storing. So data warehouse is nothing but collection of data marts, or online analytical processing is called data warehouse. To store huge volume of data in a server or a data center is called data warehouse. Once we are storing in a data center or servers, what we are going to do? Extracting meaningful data by using various classification, clustering, and association rule mining techniques is called data mining. Deals with big data sets like volume, velocity, variety, that is called big data technologies by using Hadoop, Spark, uh, Scoop, Hive, HBase, etc. The final term is data science. It is the extracting insights by applying statistical and science, machine learning and deep learning algorithms. That is called data science. Can anyone answer to my question? What is the technical name of this image? Can anyone give answer in the chat box? Hello, sir. My voice is audible.
Yes, sir, it is audible only.
My dear students, my dear faculty members, is there any technical name of this image? I have incorporated everything in this image. If you see programming, algorithm, solving, knowledge, process, system, data, database, visualization, methods, everything I have incorporated. If you see how you are publicizing about Vellore Institute of Technology by using pamphlets, by using SMS, WhatsApp, dashboards, scorecards. Same way, this is one more way of publicizing about data science. The technical name of this image is called data science word cloud. Just keep in mind, it is a technical jargon of data science word cloud. Then today I am going to explain what is data science, prerequisite for data science, solving problem with data science tools, data science applications, data science jobs, need of data science. So data is a central to data science. Data are characteristics or information, usually numeric data, characteristic data, audio data, video data that are collected through observation. That's why data is a central to data science. Types of data, there are two types of data usually we are discussing in the real-time environment. Categorical data, numerical data. We see categorical data example, marital status, political party, eye color, etc. Numerical data, again, we are classifying into discrete, continuous. Discrete is nothing, example, number of children, defects per hour in any software, that is counted items. Continuous item means our age is continuously growing. Sometimes our weight also continuously growing, voltage continuously growing. That means measured characteristics is called continuous data. So how do we collect the data? With the help of data collection tools. We are getting the data with the help of. So data science is a multidisciplinary subject. It uses scientific method, set domain, data engineering, etc. So that's why data science insights from
Sir, you are not audible. Hello.
aggregating, manipulating the data to perform advanced data analysis. So there are 7 steps we are following in this data science. The first step is collection and acquisition of data. The second step is storage of huge volume of data. Then third step goes to preparing data sets for their users, that is called cleaning. Then integration, multiple data sets we are integrating as an input data set. Then fifth step, analysis by applying tools and techniques. Then sixth step, representation and visualization of our application. Then finally, actions, managerial and policy implications. So where the data is coming from, data is everywhere, and it can help organizations, any industry in many different ways. Data has become too complex and too dynamic to be able to process the data, storing the data, analyzing the data, and to manage with the traditional data tools. So data coming from our data sources are social network data, financial data, multimedia data, mobile apps data, Internet of Things, data from ERP systems. Then data science workflow. first we are capturing the data, then manage and clean the data, exploratory analysis, then final analysis and reporting the data with the help of bar chart, pie chart, line chart, etc. So data science characteristics are volume, velocity, variety. You can also consider these dimensions are characteristics of big data and as well as data science. Volume says that size of the data, it may be megabytes, gigabytes, terabytes, petabytes. Data variety says that kinds of data, types of file formats, audio, video, text, graphics, animation, structured data, unstructured data, semi-structured data. Velocity says that the speed at the motion of the data, whether we are dealing with batch processing data, periodic data, near-time data, real-time data, etc. That is called velocity. So the first concept I am going to explain, introduction to data science. It is the process of examining large amounts of data of a variety of types, maybe big data, unstructured data, structured data, semi-structured data, to uncover hidden patterns, unknown correlations, and other useful information by using machine learning, deep learning techniques. That is called data science. And you
Hello, sir, you are not audible.
is audible.
Now it's okay, sir. Yeah, sometimes it is breaking, sir. Hello.
Sir,
Hello.
yeah, maybe internet.
Yeah, please proceed, sir. Please proceed.
So why do we learn? Why do we learn data science? So there are there are 5 reasons. It is a fuel of 21st century, problem of demand and supply, a lucrative career. Data science is changing the world. Data science is future. So it helping senior staff make better informed decisions. Data science can add value to any business who can use their data well. So data science is valuable to any company in any industry. That's why we are care about why we are learning data science. So these are the data science tools we are using. SAS, statistical analysis software, Apache Spark, BigML, D3, JavaScript, MATLAB, Excel, GZP, Plot2, Tableau, Jupyter, Matplotlib, Natural Language Toolkit, Scikit-learn, TensorFlow, Weka. These are the various data science tools and a few more frameworks like TensorFlow, Keras, PyTorch, and a few tools like Hadoop, Apache Spark, SAS, MATLAB, Tableau, BigML, Matplotlib. These are the data science tools. Important. So data science tools for small business, you can use Google Analytics, Excel, Burst, Crazy Egg, Kissmetrics, ClickSense, Insight Square, Tableau, TIBCO, Spotfire, Clear Story Data, etc. And if you see few more data science tools, Tableau, Excel, RapidMiner, Data Robot, ClickView, H2O, TensorFlow, BigML, Snowflake, Trifacta. These are the data science software, top 10 software we are using. These are the data science algorithms we are using. Starts with linear regression, logistic regression, decision tree, naive Bayes, K nearest neighbor algorithm, support vector machine, K means clustering, principal component analysis, neural networks, random forests, etc. So if If you are a data scientist, you must have knowledge on any one programming language like Python or Java. So we are generating data visualization with help of Tableau, Power BI, Matplotlib, ggplot, Seaborn. You must have knowledge on IDE, any one IDE integration development environment like PyCharm, Jupyter, Collaboratory, Spider, RStudio. Web scraping like Beautiful Soap, Scrapy, URL deployment relates to Amazon Web Service, MS Azure, etc. Mathematics knowledge like reinforcement learning, dimensionality reduction. So top logistic regression, k-means clustering, transformation. We are using various tools to develop the model. We are having various models, visualization, other tools, etc. Applications of data science, image recognition, speech recognition, price comparison websites, gaming, delivery logistics, internet search, digital advertisements, delivery logistics, recommender system, fraud and risk detection. These are the various applications of data science. Hello? Hello, sir. My voice is
Yes,
audible.
sir. Yeah, it's audible. Please proceed, sir.
Yeah. Data science applications like e-commerce applications, manufacturing applications, banking, healthcare, transport, finance applications. Data science use cases. If you see Amazon, why they are using data science? Improving e-commerce experience. That is the reason they are using data science. And why Uber is using? Uber is using optimizing rides. Bank of America, they are using increasing customer experience. Airbnb, why they are using improving searches. Data science in pharmaceutical industries, predictive modeling for maintaining oil and gas supply, data science in biotechnology, data science in education. Then what are the advantages of data science? Data science can be a fun, multiple jobs, designations, ease of job handling, customize the products, a highly paid career, cost optimization, artificial intelligence is the future. If you see few more advantages like highly paid career, higher demands, bright future, multiple jobs profiles. Disadvantages like complexity, data may be a complexity, less accuracy, no data security. So I'm going to explain machine learning. So machine learning is nothing but learning from the observational data. Machine learning can be produce accurate results and analysis. The field of machine learning is concerned with the question of how to construct computer programs that automatically improve the with experience. The famous definition given by the Tom Mitchell. So machine learning is the study of computer algorithms that improve automatically through experience and can learn and adapt new data without human intervention. The technical name of this machine learning is Machine Learning Word Cloud. I have incorporated all the tools and techniques, everything in this image. So how machine learning algorithms can. First, we are developing training model, then creating, then prediction, then analysis. If it is not so Reinforcement learning is nothing but based on the label, we are etc. Classification is nothing but classifying the groups based on the target class based on the label. Naive based classification support vector machine k nearest neighbor. Unsupervised learning is nothing but there is no label, there is no target class, but we are classifying the data based on the similarity measure. In order to calculate similarity measure, we are using Euclidean distance, Manhattan distance, Minkowski distance, clustering and dimensionality reduction. In clustering, we are using k-means and k-midpoints. In dimensionality reduction, we are using PCA, LDA, principal component analysis, feature selection, linear deterministic analysis. Reinforcement learning is nothing but based on the punishment and reward, we are solving the applications, especially gaming applications. There are various algorithms I am going to demonstrate. So machine learning, first help of order system, we are giving input to the system with artificial intelligence, and machine learning can learns itself and predicts and improves the output. So there are three types of machine learning. Supervised learning based on the task driven, all data is labeled and the algorithms learn to predict the output from the input data. That is called supervised learning. Unsupervised learning is nothing but there is no label, there is no target class. All data is unlabeled and algorithms learn to inherent structure from the input data. Unsupervised learning based on the data driven. Reinforcement learning, it works on interacting with the environment, whereas the supervised learning method works on given sample data or example. Learning from the errors, it is called a reinforcement learning. If you see supervised learning, I have explained, the algorithms learns relationship between specific inputs and outputs based on the training data and the human feedback. Example, regression classification. Unsupervised learning is nothing but the algorithms analyze the data for trends and patterns without being given a specific output variable or human feedback. Examples, clustering, dimension reduction. Reinforcement learning, the algorithm learns over time to maximize returns based on the rewards it receives for performing certain actions. Model free and model based. See here, supervised learning based on the task driven, unsupervised learning from data driven, and reinforcement learning from the errors. So if you see the machine learning model, first learning, that means big data we are giving in. You can ask the query and it can the results is not coming. So machine learning life cycle, first data gathering, then model training, model testing, finally prediction, then stores the feedback. So machine learning examples, self-driving cars, credit worthiness, predicting an illness, banking on soil media, computer vision in agriculture, targeted emails, question and answer based platform, fashion industry, etc. So this is the brief overview of reinforcement learning. I'm going to explain. Please listen. So there is a chatbot or robot or agent, left side bucket with full of water and right side fire. So agent is observing the first step. select action using policy. If it wrongly step into the fire, which there is minus 50 points. So that's why then it realizes, and left side it will bring a bucket with full of water and pour onto the fire. So if it moves bad step, it gets punishment, and if it gets good move, then it gets reward. That means based on the punishment and reward, we are solving the problems, especially in gaming applications. That is called reinforcement learning. It is a small overview. Then machine learning approaches, we are having supervised learning, unsupervised learning, ensemble learning, neural networks and deep learning, reinforcement learning. There are various techniques in each approach. In supervised learning, we are having again regression and classification. Unsupervised learning, we are having clustering, association, rule mining, dimensionality reduction. Ensemble learning, we are having stacking, bagging, and boosting. In the neural networks and deep learning, we are having perceptrons, autoencoders, and generative adversarial networks, that is called GAN. Especially GANs are used to develop facial expressions from childhood to adult age. Such type of applications we are changing. We are using GANs applications, generative adversarial networks, recurrent neural networks, convolutional neural networks. There are various techniques again further classified into. This is called mind map of machine learning. Then predictive analytics strategy. First, we are doing pre-processing. We are eliminating data, five-fold cross validation. Then I am doing feature selection, folded cross validation of multiple data sets as input to the system. And that five-fold cross validation specificity, precision, recall. With the help of that one, we are validating our application. So traditional programming tools and machine learning tools. So traditional modeling, human intervention is there. So prediction, data, handcraft model, computer, and results. Machine learning, see here, learning and prediction. So it learns itself, and sample data, expected results, new data, model. Then finally we are getting model and result. So types of machine learning approaches, I have explained supervised learning. Based on the target and the label, we are dividing the classification, regression. Example of classification: fraud detection, email spam detection, diagnostics, image classification. Regression, you can see risk assessment and score prediction. Unsupervised learning, there is no label, there is no target class, but we are dividing the classification based on the similarity measure. Similarity measure, we are calculating with help of Euclidean distance, Manhattan distance, and Minkowski distance. Unsupervised learning can be classified into dimensionality reduction and clustering. Examples for dimensionality reduction: text mining, face recognition, big data visualization, image recognition. Clustering, a group of objects, that objects are having similar behavior. So biology, city planning, targeted marketing examples. Reinforcement learning, learning from the observational data based on the punishment and reward, especially gaming application, finance sector, manufacturing, inventory management, robot navigation, etc. So supervised learning, examples, regression, decision tree, random forest, in classification KNN, K nearest neighbor, trees, support vector machine. In regression, linear regression, polynomial regression. Learning, clustering, support vector dimension, principal component, support vector discriminant, principal algorithms, categorical algorithms like association analytics, like association rule mining. In order to generate frequent items under categorical data. Then finally reinforcement. State and action, model free and model based. Model free, we are having algorithms like Q learning, hybrid, policy optimization. In model based, learn the model, given the model. Remaining all algorithms I have explained. So these are the algorithms I have already explained. Supervised and unsupervised learning. So in clustering, you can see K-means clustering, hierarchical clustering, Gaussian mixer model, genetic algorithm, artificial neural network. Dimensionality reduction, principal component analysis, tensor decomposition, multidimensional statistics, random projection, artificial neural networks, etc. See, this is one more diagram related to this machine learning approaches. Regression. Why do we want to use regression? Forecasting the temperature, predictions of the price, process optimization, new insights. Classification, where we are doing fraud detection, image classification, customer retention, diagnostics. If you see unsupervised learning, clustering, and dimensionality reduction. In dimensionality reduction, big data visualization, meaningful compression, structure discovery, feature elicitation. Clustering, recommended systems, targeted marketing, customer segmentation. Reinforcement learning, real-time decisions, game AI, and learning tasks, skill acquisition, robot navigation. So these are the machine learning algorithms. So how do we use a linear regression, classification regression tree, K nearest neighbor, machine learning, supervised support vector machine, Q learning, linear discriminant analysis, logistic regression, naive-based classification, learning vector quantization, random forest, boosting and ADA boost. These are the in this expert lecture I am going to demonstrate. These are the machine learning. So I have collected from the Spring SPSS, PES, PP, stats, SciPy, NumPy, etc. General purpose, we are using Wabit, linear, SVM, library linear, library support vector machine, natural language toolkit, and NTLK, GenSim, interactive platforms like Jupyter, Zeppelin, Orange, Hibana, Grafana, Tableau. Then machine learning, deep learning with the MapReduce, deep learning 4J, H2O, deep water, Spark ML, machine learning library, Flink ML, RCX2 ML, deep learning with GPU, graphical processing unit, TensorFlow, and CNTK, Cafe2, Torch, PyTorch, MaxNet, Theano, Chainer, Paddle, MAT convolutional network, deep learning wrapper libraries like Keras, Gluon, Tensor Layer, TF-Learn, Leasing 9, NVIDIA Digits. Hello, sir. My screen is visible.
Yes, sir. It is visible.
Hello, sir.
Yeah, it is visible, sir. You can
Yeah.
proceed.
Yeah. Thank you, sir. So these are the various approaches I have already explained. And if you see machine learning roadmap, so first you need to have mathematics knowledge like probability and statistics and discrete knowledge, anyone programming knowledge like Python or Java. Database, you can use relational database tools like SQL, MySQL, Teradata, DB2, MS Access, or relational non-relational database tools like Mongo database, Hive, HBase, Zookeeper, Scoop, Cassandra, etc. Then machine learning, it uses scikit-learn, and then machine learning can use libraries, non-machine. Then machine learning algorithms like linear, k nearest neighbor. Then you can choose deep learning like TensorFlow, Keras, natural neural network, CNN, RNN, GAN, generative adversarial network, LSTMs. Then data visualization tools like Tableau, ClickView, Power BI, etc. Finally, you can become as a machine learning engineer. So machine learning engineer can perform all types of tasks, whatever I have mentioned. Then machine learning analytics tools, we are having statistical tools, exploratory data analytics tools. So pandas, especially pandas is a machine Python library. You can explorate data analytics. Then predictive model markup language. Then scikit-learn, it is a machine learning model builder. Portable format for analytics, Mongo database, scriptable databases, Hadoop, it is for big data analytics tool. Then Spark, interactive analytics, Storm, real-time analytics, client-side web browsers, graphical processing units, GPUs and processors, FPGAs and ASICs. And there are various machine learning tools. We are having traditional pipeline and a new pipeline and data acquisition tools, data engineering tools, machine learning tools, end-to-end tools, and finally operations. Then these are the top 10 machine learning algorithm softwares: Veka, Apache, Spark, MLib, RapidMiner, H2O, Shogun 9, RCX2, Apache Mahout, PyTorch, TensorFlow, Keras. These are the libraries we are using in machine learning by using Python. Advantages like easily identifies trends and patterns, no human intervention needed, continuous improvement, handling multidimensional and multi variety of data, wide applications, etc. Disadvantages in machine learning: highly error susceptibility, data acquisition, interpretation of results, time and resources. These are the disadvantages. Slowly, the researchers are, erasing these are the disadvantages. Still, R&D is ongoing. Applications of machine learning, especially we are using image processing and speech recognition applications, medical diagnosis purpose, statistical arbitrage, learning associations, especially in classification, prediction, extraction, regression. These are the applications of machine learning, and a few more applications of machine learning automatic language translation. Suppose I don't know Chinese, I want to learn by using translator tools. So that is called automatic language translation, medical diagnosis, stock market trading, online fraud detection, virtual personal assistants, email spam and malware filtering, self-driving cars, product recommendations, traffic predictions, speech recognition, etc. And these are the data science main formulas for machine learning: naive-bayes formula, perceptron, linear regression, k nearest neighbor, neural networks, principal component analysis, support vector machine, back propagation, logistic regression, gradient descent. These are the very important formulas in order to calculate mathematical model. So what are the major challenges faced by machine learning professionals? Poor quality of data, underfitting of training data, overfitting of training data, lack of training data, imperfections in the algorithm when data grows. These are the major challenges of machine learning. Still R&D is ongoing in order to avoid such kind of challenges in the near future. So machine learning code libraries, I have used various machine learning libraries like NumPy, SciPy, Scikit-learn, Theano, TensorFlow, Keras, PyTorch, Pandas. I'm going to explain in the algorithms when I have used these libraries. Algorithms for predictions, especially linear regression, logistic regression, etc. So these are the top 10 classification algorithms in machine learning: logistic regression, decision tree, support vector machine, naive-bayes classification, k nearest neighbor, etc. So now I'm going to please. If you are having any doubts, please ask me. Hello, Professor. Please unmute them. Let them ask any queries on data science and machine learning theory concept. Now I am going. Hello, sir.
Yes, yes, sir. Yes, sir. Proceed.
No problem.
Yeah, sometimes it is breaking, sir. Otherwise, it is fine. Okay, sir. You can proceed.
Yeah. So logistic, sir. How many students are there right now?
Now 94 are attending, sir. 94.
Yeah. If is there any doubts with them, please ask them,
They
sir.
will ask, sir. If they have any doubts, they will ask. Okay, sir. Huh?
Okay.
Yeah, yeah. You
Okay.
please
So
proceed.
now
Yeah.
I am explaining logistic regression.
Yes, sir. Yes,
So
sir.
based on binary value, one for true and 0 for false, one for one classification of males and 0 for female classification, suppose. Such type of applications I am developing with help of logistic regression based on the binary in nature. It is estimating the parameters of logistic model, a form of binary regression. This is the example. If you see x-axis and y-axis. So first one is a linear regression and second one is a logistic regression. So I'm going to demonstrate a logistic regression now. So I'm taking input values x1, x2, x3, x4 and I'm developing the linear model. I'm getting the probabilities like 0 0.5, 0 0.8, 0 0.1, 0 0.2. I'm applying activation functions like sigmoid, ReLU function, etc. and values between 0 and 1. So finally, I'm getting the output 0 or 1. That means classification. So now this is the logistic regression code I'm using in Python. So I have used matplotlib for visualization purpose. I'm using matplotlib for visualization purpose. I have hello sir, my voice is audible?
Yes, sir. It is audible, sir.
Yeah, NumPy is a library in Python, and I'm using scikit-learn, that is a sklearn linear model. From there, I'm deriving logistic regression. So then I'm classifying the report and generating the confusion matrix. So I'm taking x-axis with range 10 values, y-axis I'm taking 0 and 1 outputs, then print x and y values, then logistic regression uses a linear model, and then finally I'm fitting the model of x comma y. So I'm generating the score values like intercept value, scaling, maximum iterations, and all the parameters I'm assigning. Then I'm developing logistic regression. Here I am going to display predicted classes, intercept value, quotient value, predicted value, model prediction. Finally, I am showing. So this is the demonstration. I am using a logistic.py, and now I am going to show you practicals. Please, if any doubts, please ask me. I am going to clarify.
Participants, please do raise your hand if you have any doubts.
My screen is visible, sir.
Yes,
Please.
sir. It is visible. Yeah.
Yeah. Now see, I'm using Python 3.10.8. The latest version is 3.11.0 is available right now. So Python can be executed in two ways. One is IDLE, integration development learning environment, and a scripting way. If you use Python, this is interactive mode. Here simply you can perform any operations likewise. Suppose addition of two numbers. I'm showing sample example. So this is the way you can execute in IDLE, that is interacting mode. So this is called Python is an interpreted language. See, now I got the result 7 because I'm performing addition of two numbers. So same program you can execute in the scripting way by using this command. If you want to go to scripting way, you can use like this and you can demonstrate. So now I'm demonstrating linear regression, logistic regression, and non-linear regression, etc. Please see here Python. First, let me open the program, Notepad, and linear.py. This is the program. Suppose linear regression. My screen is visible, sir. Please acknowledge me.
Yes, sir. It is visible.
So this is a linear regression. This is the first regression model. I have used NumPy, scikit-learn. It's a library. From that sklearn library, I'm deriving linear
Participants, you can
regression.
show the hand symbol if you have any doubts, please. Yeah,
Any
sir. Proceed. Go ahead, sir. Go ahead.
So I'm using array values 5, 15, 25, 35, 40, and I'm generating the linear regression model. Please see here Python space py. So I'm executing linear regression model right now. Sir, my screen is visible. I got the results.
Yes, sir.
Visualization graph is visible.
Yes, sir. It is visible.
Hello.
Yes, sir. It is visible. We
Sir?
can see the graph. Yeah.
Rated. See here. Yeah, and I got the values like before reshaping NumPy array, and I'm calculating quotient value, I'm calculating intercept value, I'm calculating the slope, I'm calculating the predicted responses by using linear regression. This is the way you can use linear regression model. Then next see. Next, one more non-linear regression model I am going to demonstrate. So, notepad space non-linear regression model. This is one more second second algorithm, that is in linear regression. Here also I am importing NumPy. I am using matplotlib. I am using x values. I am using y values. I am calculating the non-linear regression. So np dot power of x comma 2 and y noise value to multiplied by random value, and I am generating the graph. Now see here Python space nonlinear.py. I am executing. See, hello my dear students. My screen is visible. Hello sir, my screen is visible.
Yes, sir.
Yes, sir.
Yeah, it is independent variable and dependent variable. I have generated non-linear regression. Now I am going to generate a third application, logistic regression. See here, I am generating a logistic regression. I got the output and graph generated. I have generated graph, and see, these are the values, predicted classes 0 or 0 comma 1, intercept value, quotient value, predicted values. So this is a logistic regression. Now I'm going to show you next algorithm. So decision tree. So before going to decision tree, let me explain what is meant by decision tree. It is a flow chart like a tree structure where each internal node, non-leaf node, denotes a test on an attribute. Each branch represents the outcome of the test, and each leaf node holds a class label. So induction is developed by Ross Quinlan, and decision tree algorithm known as ID3 because iterative dichotomizer. Decision tree is a classifier in the form of tree structure by using decision node, leaf node, arc or edge, path, etc. Classification by decision tree induction consists of decision tree induction, attribute selection measures like information gain, gain ratio, Gini index, tree pruning, scale class, whether student buys computer or not, attributes are integrating, etc. These are the student can able to purchase a computer based on the his means he cannot purchase the computer. That is the target class. So this is the decision tree. Age. Based on the age, we are classifying youth, middle-aged, senior. Youth means student. Again, no or yes. Middle-aged, yes. Credit rating. If it is fair, he cannot purchase the computer. If it is excellent, he can purchase the computer. So this is the Python code in for decision tree. So import pandas. See, I'm using pandas, NumPy, Matplotlib, Seaborn, scikit-learn, etc. And these are the libraries, Python libraries I'm using. Now I'm going to demonstrate this one, this decision tree, and you can see the output of this decision tree. See, now I'm going to demonstrate. Now, let me check. See here in this folder, I have executed decision tree. So decision tree and random forest regression decision tree, I'm going to execute. So Python, I'm executing Python decision tree. Now it is, see, sir, my screen is visible.
Yes, sir, it is visible.
Yeah, my dear students, please see here 714 rows are there, 3 columns are there. 714 columns and sorry, 714 attribute, I mean rows, tuples, instances are there, 3 columns. So age, fair, whether he can purchase computer or not. So this is the output of a decision tree. And one more random forest I'm going to demonstrate. Python space random forest. Now it is executing. First step, first iteration. If you see now random forest algorithm is executing 40% of input data completed. Number of iterations, 10 iterations, 50% completed. This is called random forest. So now the program is running. 70% is completed. A random forest. So 10 by 10. Now the last step is running. See here. Hello, sir. My screen is visible. The training precision. I got 0.84
Yes,
and
sir,
the
yes,
training
sir.
recall
Yeah, we can
0.38.
see the output. I think it's
Yeah.
0.3850. Yeah,
So this is
correct.
the random forest output. Now I'm going to demonstrate one more. Uh, random forest regression decision tree.py. If you see this one, see I got the output of a regression decision tree. See split rule. I got this is the output of a regression tree. Now I am going to demonstrate support vector machine. Okay. So if you see Python space svm.py support vector machine. See, I have taken a heart disease data set. So I got precision recall FN accuracy and my support vector machine. Machine learning algorithm capable of drawing a straight line between two classes. Support vector machine. Based on the hyperplane, we are dividing into two groups based on the values, margin values. So in this support vector machine, I'm using pandas, scikit-learn, etc. From sklearn, import metrics like classification report, confusion matrix, and columns variance like skewness, kurtosis, entropy. Assign column names to the data set. Read data set pandas data frame. Then I'm selecting the RDF kernel classifier and I'm printing the confusion matrix and I'm printing the classification report. I'm getting model accuracy. How often is the classifier correct? I'm printing accuracy, metrics accuracy, precision, etc. If you see the output, so I got the output total 275 records I have taken instances. I have generated a confusion matrix. So precision recall FN square support. I got accuracy 0.99 means 99%. Precision 0.98 recall. So this is called support vector machine. Any doubts? So next one is a naive-Bayes technique. I'm going to explain naive-Bayes algorithm. It uses 7 easy steps. Separate by class, summarizing data by class, Gaussian probability density function, class probabilities, and stop. So these, based on this formula, probability of A by B equal to probability of B by A multiplied by P of A by probability of B. That is called posterior is equal to prior multiplied by likelihood by evidence. P of H by E, that means likelihood of the evidence given in the hypothesis is true. Prior probability of the hypothesis, prior probability that the evidence. See, this is the example of by using naive-Bayes classifier, by using Gaussian naive-Bayes scikit-learn. It is or forecast. So this is the code I have used. Naive-Bayes I have used the square root, exponential, pi value. Then finally, I have demonstrated naive-Bayes.py. I'm executing. this program now. Then support vector mission hard data set, input data set. I have explained this one. I got 62%. Then K nearest neighbor. So by using K nearest neighbor algorithm, initial data set and class A, class B, two classes I'm going to divide, two colors. Calculate the distance by using Euclidean or any formula, mathematical formula I can use. Minkowski distance, Manhattan distance, finding neighbors and voting for labels, and classifier building in scikit-learn. This is the algorithm. This is the KNN technique using Python. So this is the output I'm going to demonstrate now. My dear students, if you are having a mobile phone, please subscribe my channel, Dr. Asadi Srinivasulu. You can type in YouTube. You will find 52 videos I have uploaded in my channel. You can subscribe and listen and ask any doubts related to these technologies, data science applications using machine learning and deep learning techniques. Thank you for subscribing my channel and support me while writing comments. Now I'm going to demonstrate the remaining applications. Please see here. Yeah. So I'm executing Python space knn.py, k nearest neighbor. So now it is executing. See, sir, my screen is visible.
Yes, sir, it is visible.
So 68.51% I got accuracy for k nearest neighbor algorithm. And so I'm demonstrating one more application, Python naive base.py. See, I got 93. Me, say I got 95. So naive base class ann.py. Please see here, sir. My screen is visible.
Yes, sir.
Please acknowledge me. Yeah, 94.04% of accuracy. I got it for a number of iterations I have performed. So I have uploaded 150 epochs, number of iterations, 15 steps I have run, loss, and 94.04. And one more algorithm I am executing, Python space spm1.py, support vector machine. So in this, for a heart disease data calculation, I got 63%, precision 0.6, recall 0.80. So now I'm going to explain deep learning techniques. Sir, how much time is there?
Hello. Sir?
Hello, sir.
Sir, you have 10 minutes
Sir,
more, sir.
how much time is?
You have 10 to 15 minutes
That's
more,
all?
sir. Yeah.
Oh,
Hello.
what is current? Okay.
You
So
know,
shall I demonstrate a deep learning algorithm, sir?
yeah, of course, sir.
KNN.
Yeah.
Yeah. So these are the theory part I'm skipping now. So in deep learning, we are using various models, and this is theory part of deep learning. I am going to share with you this PowerPoint presentation to your coordinator. Your coordinator will share with you. These are the three algorithms we are using: deep neural networks, convolutional neural networks, recurrent neural networks. DNN, it provides lift for classification and forecasting models. CNN, it uses feature extraction and classification of images. For sequence of events, language models, time series, recurrent neural networks, etc. Deep learning models, supervised models, unsupervised models. So I can use convolutional neural networks. See here, these are the three models I'm using: CNN and RNN and LSTM and GAN. CNN is a neural network, especially for image recognition and processing, that is specifically designed to process pixel data. RNN, for in order to sequence classification, we are using recurrent neural network. And Apache MaxNet, and applications of deep learning the images, clip movements, photo descriptions, deep learning, advertising, etc. These are the top 10 latest application that uses deep learning: autonomous vehicles, and PolyB, and RNN noise, Grammarly, and Perlmutter, Meridian, Neural Brain, and Zero Eyes, WaveNet, Sixth Sense, Robbie A. These are the latest applications. These are the top 10 fascinating applications of deep learning: self-driving cars, automatic handwriting generation, pixel restoration, colorization of block and white images, deep dreaming, detection of growth delays in children, demographic prediction, sound addition to silent films, news aggregation, automatic mission. And these are the top 20 deep learning applications: self-driving cars, entertainment, visual recognition, visual assistants, fraud detection. See, natural language processing, news aggregation and fraud news detection, detecting developmental delay in children, colorization of black and white images, adding sounds to silent movies, healthcare personalizations, automatic mission translation, automatic handwriting generation, demographic and election predictions, automatic game playing, language translations, pixel restoration, photo descriptions, deep learning. Python deep learning applications. I have explained this one. And these are the most deep learning tools in 2022. Neural Designer, H2O, Deep Learning Kit, Microsoft Cognitive Toolkit, Keras, Convolutional Net.js, Torch, top open source deep learning tools: Anomaly, Marine, Google Assistant, RS, fMRI, CNN, LSTM, etc. And top 10 algorithm: TensorFlow, Keras, PyTorch, OpenNN, and Microsoft Cognitive Toolkit, Apache MaxNet, Deep Learning Kit, Deep Learning 4J, Darknet, Played ML, challenges of deep learning, learning without supervision, coping with data from outside the training distribution, incorporating logic, performance hardware requirements, data availability, not issues with flexibility and multitasking. So these are the top 10 for my applications: NumPy, SciPy, Theano, TensorFlow, Keras, Python, SciPy, Pandas, Scikit-learn, application, and healthcare applications I am going to demonstrate. The first application, COVID-19 virus prediction and detection using convolutional neural network. These are the symptoms. This is the clinical and imaging features of COVID-19 patients. These are the steps of CNN, convolution operation, ReLU layer, pooling, flattening, full connection. These are the algorithm steps. And this is the sample architecture. This is the corona training data set to the CNN model. This is the algorithm steps of COVID-19. This is the code. Import the sequential model and the layers. I have used training augmentation configuration, testing augmentation, rescaling, and generates batches of augmented image data, generator for validation data, evaluating model performance and testing. And this is the testing data. X-ray 975 images. This is just X-ray image of COVID-19 and severity levels final output. And these are the number of epochs I have performed. I have executed execution flow of COVID data set. Then this is the data loss versus accuracy, execution time between COVID-19 virus data set and the number of process. This is the differences between size versus accuracy. Then COVID-19 strain virus detection. Same way, these are the symptoms of the Omicron virus. This is the input data set. This is the training data set. This is the code by using RNN algorithm. Import COVID-19 data set, training parameters, network parameters, and TensorFlow graph input, define weights, and get LSTM cell point, linear activation using RNN inner loop last output, define loss and optimizer, evaluate model, initialize the variables, start training, run this. So reshape data set, run optimization, calculate batch loss versus and accuracy, calculate accuracy for 128 MNST data set. So far, Hello, sir. My screen is visible, sir.
Yes, sir. Visible, sir. It is visible.
Yeah. So I have opened COVID-19. Images I have collected. Sir, now see my screen. I am demonstrating CD space COVID-19. Sir, my screen is visible, sir.
Yes, sir.
Hello, sir.
Yes, sir. It is visible.
Yeah, COVID-19 folder I have created and yeah, CNN.py, convolutional neural network I'm executing right now. Please see here, Python space CNN.py. Now my program is running. Yeah, please ask me doubts now. So two class classification. So now the program is running. So I will reduce the screen so that it will be font size. I will reduce. See now my screen is visible, sir.
Yes, sir. Visible.
Hello, sir. My screen is visible.
Yes,
Yeah,
sir.
please.
Visible.
Now
Visible.
in COVID-19 classification, it is running. Yeah, 3 approaches only I kept. 3 iterations. Now you can check the values. Now see, I'm getting the accuracy 63%. Now see here, sir, I got a final accuracy. Only 3 steps I have kept. If you keep 50 or 30 epochs, you will increase the accuracy and classification accuracy. Okay. Set, please see here. Sir, my screen is visible. You see the accuracy. I got 92.50 accuracy for a COVID-19 virus prediction and detection. Now I am going to demonstrate Omicron virus. Please see here. Omicron virus. So Omicron virus, what I am taking, the input data set I have collected CT scan images. Sir, my screen is visible.
Yes, sir. Visible, sir.
Hello, sir. My screen is visible.
Yes, sir. Visible.
Yeah,
Visible.
these are the images I have collected. Nearly 7,750 images I have collected. Omicron virus and Omicron testing images. So now I am going to execute. So same way, I am going to show you this execution and followed by the monkeypox also. I'm going to show you the data set where I have collected monkeypox. If you see monkeypox images I have collected through internet. See, these are the images I have collected, monkeypox images. And these are the testing images. These are the training images. Sir, my screen is visible.
Yes, sir. Visible, sir.
Yeah, now I'm demonstrating Omicron virus. Please see here. So Python, you can see in this folder. I'm going to share these folders to your coordinator. All latest applications I have executed. Omicron virus prediction detection, COVID-19 virus prediction detection, monkeypox virus prediction detection. So various latest applications I have executed. You can ask to your coordinator. I'm sharing all these. How the application is running. Total sir, please unmute them. They can ask any queries because I'm executing all sort of images. So this is my channel. My dear students, if you are having any doubt, just open your laptop or mobile phone. Please, if you are having mobile phone, just open YouTube. Type my name, Dr. Asadi Srinivasulu. Please, just open your mobile, go to YouTube. Just do favor for me. Go to YouTube channel, YouTube, type my name, Dr. Asadi Srinivasulu, and subscribe. And whenever you are getting free time, listen all those videos and contact your coordinator. Will share my details to my details, my email ID and mobile number. You can subscribe and listen my videos. I'm concluding my session. Still, execution is ongoing. These are the various expert and guest lectures I have conducted. This is at Thailand. This is at Singapore. This is at the Philippines. This is at the keynote speaker at Geetham. This is at MITS Madanapalli. This is a resource person. It is jury member. It is keynote speaker, one of the engineering college. Doctorate degree from JNTU Anantapur. It is a Bharat Vidya Ratan Award from Delhi. And this is Best ITAP Teacher Award from Tutors Pride. This is Best Local Chapter Award from IIT Madras. And this is an international seminar at Salem. It is at Gautami Engineering College. And this is at ISER, Tirupati. This is Sangam University. This is ABS College, Ghaziabad. Jaya Engineering College, Tamil Nadu. Maharshi Markandeya Engineering College. Data Science at Bluecrest. It is at Oman, Big Data Analytics using Spark. It is at Bluecrest. It is at Russia. I have demonstrated COVID-19 strain virus detection. One of the university called Ural Federal University in Russia. This is big data applications at Bluecrest. It is at Russia. And this is a data science application hands-on. This is Bhartiyar University. And this is Lord's Institute. This is data using R programming. This is Rava University, Karpaga Vinayaka College of Engineering, Vijnana Bharati. This is at West Africa. This is at Krishna University, KL University, Vijayawada, Chadalavada Engineering College, Annai Sala Engineering College, Chalapati Engineering College, Namachar Institute of Technology, Cyber Security Applications using Python, Bluecrest, at Bluecrest Cyber Security Applications, Maharshi Markandeya Engineering College, Mobile Application Development using Python, Vet Institute of Arts and Science. This is one of the Bangalore University. This is at Saudi Arabia. This is at one of the security. This is Mahendra Engineering College, Bansal Engineering College. This is one of the Model Institute of Engineering College, Rathinam College, Coimbatore, Srinidhi Institute of Science and Technology, and one of the DCS MAT, Vagaman. This is at MVGR Engineering College, Aditya Engineering College, and Sri Sai Ram Engineering College, Bluecrest University, Research India Foundation, and this is at Kadapa Engineering KSRM Engineering College. This is at SRIT Engineering College, New Origin Engineering College, Krishna Chaitanya, Vellore Institute of Technology, Savita Engineering College, Bluecrest Data Science Applications, Madanapalli MITS Engineering College, Bluecrest. This is Sri Vishnu Engineering College today, and this is my channel. Please, any queries, please ask me now. See now, still R&D, this program is executing. See how many iterations still program is running. Any doubts, please ask me now. My dear students, sir, please unmute them.
Yeah.
Hello. Yeah, please ask me any doubts. John Singh, sir, please
yes,
unmute
sir,
them. Hello, sir.
Yes,
5
sir.
minutes time
Yes,
is
sir.
there.
Yes, sir. Yes,
Please
sir.
unmute them.
Participants, please ask your queries.
How many participants are there total?
98 are there,
98.
sir.
Yes, sir, please. I have demonstrated health database applications and machine learning approaches, and I have explained machine learning concepts, data science concepts, deep learning libraries. Please ask me doubts now. Without asking doubts, it is not good for you. Please. My dear participants, please ask me doubts.
Sir, so if they have any doubts, they may send mail to you, sir. Shall we
Sure,
conclude
sir,
the
sure.
session? Yeah.
Yes, sir. Yes, sir. Please
Okay.
do it, sir.
Yeah. Thank you very much, sir, for your wonderful presentation. I hope everybody has understood what is data science and the importance of data science and how we can make data science based applications by using both machine learning and deep learning techniques. Okay. Let me invite Dr. Shainu to propose the vote of thanks. Over to Dr. Shainu.
Thank you, sir. Thank you. Am I audible, sir? Hello, sir.
Yes, sir. You are audible. Yeah.
Okay.
Please.
Okay. So good afternoon,
Yes, sir.
everyone. Good afternoon, everyone.
Yeah.
Good afternoon, sir. On behalf of the
Right.
School of Information Technology and Engineering (VAT), I extend our sincere gratitude and a deep sense of appreciation to Dr. Asadi Srinivasulu for demonstrating the concepts of data science applications using machine learning and deep learning techniques. Thank you very much, sir, for giving us an excellent coverage of various concepts in data science, its business applications, and interesting case studies with their demonstration as well, and also enlightening us with your knowledge and experience in this area. It was Really a wonderful session. Thank you so much, sir. I also take this opportunity to thank all the participants who attended
Thank you,
this
sir.
lecture. All the participants who attended this lecture. Once again, thank you all. Thank you. Thank you, sir.
Yeah, thank you,
my dear
participants, and you
participants,
can
if you are
leave from
having
the meeting now.
any queries, you can, if you are having any doubts, you can contact your doctor. He is going to share my details to you, and you can